Hey everyone, welcome back to my channel EduVibe. Today we will completing the unit of momentum and impulse with the diploma questions. So as you all know that grade 12 physics, which is physics 30, is the diploma course, and you have a diploma for this. So we are completing the momentum and impulse now, and we're now doing the diploma questions. So let's start with this, and our first question is the graph question. So it says that the initial speed of a remote controlled toy car on horizontal surface is 3.0 meter per second. The car then experiences a force in the direction of its motion. A graph of this force as a function of time is shown below. The mass of car is given to us, which is 5.0 kgs. Student analyze the motion of the car. One student looks at the first 1.0 seconds time interval and the other student looks at the complete 1.5 seconds time interval. So this is the force on a toy car as a function of time. So this is the graph of force and time, and we have subparts of this. So we have to find first speed of a toy car at the end of 1.0 second time interval. So we have to find the speed. So we have to find that speed. So they mentioned that we have to find by the end of the 1.0 second time interval. The 1 second time interval, which is our force. So at that, our force is this one, which is 8.0 newtons. So this means at 1.0 time interval, we have a net force of 8.0 newtons. What is the time? Time is 1.0 seconds. And mass we have given to us, which is 5.0 kg, which is the mass of a toy car. So this is also given to us. So these things are given to us and we want to find the velocity at the end of 1.0 time interval. So it's the end. So if it is start is over there and its end over there, so this means we have to find the final one. So if we have to find the final one, so what is the initial one? So initial one is given to us, which is 3.0 meter per second. That is the horizontal surface they travel, the initial speed they mentioned. So this is our initial speed. We have to find the final velocity. So basically, we have to find that final velocity, and we have VI of 3.0 meter per second. We know the formula, which is net force times delta T is equal to delta V times M. So we know that net force is 8.0 newtons, time is 1.0 seconds. That is final minus initial. Initial is 3.0 meter per second and mass is 5.0 kgs. So when we solve this, so we get 8.0 newton dot second and the 5.0 kgs goes like this, and we plus this with 3.0 meter per second and we get the final. So for final, when we calculate this, we get about 4.0 meter per second. So this is our speed, final speed of the toy car at the end of 1.0 seconds time interval. So that's how we find this with this formula, which is both are equal to the impulse, which is a change in momentum. So in the next part, we have to find the magnitude of the impulse of the toy car during the 1.5 second time interval. So this means that we have to go from here to this point. So this is all the area we have to find, but this is not like the thing we have to know that area of this type of shape. But if we cut this into like this, so we get the two areas. One is the this and one is this. So first is the area of the rectangle and second one the area of the triangle. So the triangle, this is a right angle, so this means this area has 1 into base into height, and this one has the area of length into width or the length into breadth. So from here we have to find the two areas. For the first one, which is this, so we have the length from this 0.0 to this 8.0, which is 8.0 for this. And for width, we have to find from 0.0 to 1.0, which is our width. So this is 1.0 again. So for area 1, if we calculate over there, area 1 is length into width. Length is 8.0 multiplied by 1.0. We get the area of 8.0. This is in Newton and dot second. So this is for area 1. For area 2, we have half into base into height. So we have to find the base and height from now this triangle. So for this, our base is from 1.0 to 1.5. So 1.5 minus 1.0, we get 0.5 seconds. And for the height from here to this is the same, which is 8.0 Newton as the rectangle. So we get 0.5 seconds multiplied by 8.0 newtons. Calculate this, we get about 2.0 Newton dot second. So that's how we get this momentum. But you know that change in momentum is area 1 plus area 2. So when we plus them both, we get 10.0 Newton dot second. So this is the magnitude of the impulse during the 1.5 second time interval. So that's how you have to find from the graph. There are two questions we have to. So next question we have, like, we all know that this is type of the theory based question from the maximum speed. So the rock climber falls and is saved from the injury by a climbing rope that is tightly elastic. So that the climbing rope is the last one, that's why they save their injury. The importance of elasticity of the climbing rope can be understood in the terms of impulse because the elasticity results in what? So if we have an elastic thing, so if there is a elastic type of thing, if we like climbing rope is the elastic one and there is so much elasticity which decreases the force. So if we understood from the in terms of impulse, you can understand this, that the elasticity decreases the force. If we have elasticity, this will decrease your force. So you all know that this is decrease of force. So this one or this one, or what is the impact on time? So if force is decreased, so it's inversely proportional. So the time, which is delta t, is increased. So if we do with the increased, so we get the B option for this. So in elasticity always decrease the force during the increased time interval. So that's why it is that option. That's why you have to just know that this elasticity means that net force decreases and the time increased. So next, an empty freight car of mass m, so the mass of m something, goes along the track of 2.0 meter per second until it couples to the stationary freight car of mass 2m. The final speed of the two freight cars immediately after the collision is what? So in this, the empty car mass of m goes along the track of 2.0 meter per second until it couples to a stationary freight. So couples means, so another word for couples means they are attached. So they attach to each other. The two freight cars are then attached, or we can say they stick together. So this means that this is the hit and stick collision. So for hit and stick collision, you all know that, but we have to know. In hit and stick, we know the formula, which is m1v1i plus m2v2i is equal to m1 plus m2, and we have the combined velocity of final. So to find the final velocity, you have to find this, but they mentioned that the second one, which is this is the stationary. So this is stationary, so it cuts out to 0. we have m1 of m, v1I, we have 2.0 meter per second, which is the initial velocity of the this first mass of m. M1 is m plus m2 is m2m, they mentioned over there, and we have to find this thing. So we get, so the m 2.0 meter per second upon that m plus 2m will give you 3m, so it goes over there, they multiply and those over there divide, cuts out, and when you solve 2.0 divided by 3, you get about 0.667 meter per second. So this is our final speed of the two cars immediately after the collision. So this is D option. So that's how it works. This is easy kind of question. We just not have a numbers. We have some numbers, but we deal with the m or 2m as the mass. Nothing like change in this. We just use the formula. But things which you have to know that they couples together is a new word for this type of questions, that these is stick together. So this means it's a hit and stick collision. So we have to write the right formula for this. So the next one we have the question. So let's deal with. So the two boys, Ted and the Larry, initially at rest, push each other apart on frictionless surface. They push each other. The Ted has a mass of 40 kg, Larry has a mass of 60 kg. After the boys push each other apart, Ted has a speed of 6.0 meter per second. As the boys moved apart, Lily has what thing? We have two options for them. So both are initially at rest. They push together each other in frictionless surface. Mass of one is 40 kg, second of mass 60 kg. The boys push each other and it has a speed of, so when they push to each other apart, so they have separate mass, they have a speed, and the first one has a speed of 6.0 meter per second, and the second one moved apart. As the boys moved apart, Lily has what? So they mentioned that they has a more momentum than this, they have a less momentum than Ted, they more kinetic energy and the less kinetic energy. So they mentioned about the momentums and the kinetic energy. So this means there's an interconnected theme that the initial or the final kinetic energy is something we have to know. So in this we have a mass and we have a speed of the one of them, but we don't have the velocity for this. So if we're talking about the velocity of thing, we have a masses for both and we have a speed for one, and second speed was we don't know, but we have to find that speed. So how can we find that speed? That we can see that they initially at rest. So if that initially at rest, so we all know that this is what type of thing, that bit of a collision we have. So this is the explosion one. We all know that initially explosion terms in explosion equation we have 0 in initially, then we have m1 v1 f plus m2 v2f. So we don't know that v2f. We know the rest of the things. So this is 0, mass 1 is 40 kgs, v1f is 6.0 meter per second, plus m2 is 60 kgs, and v2f we have to find. So from here, when we find v2f, there goes over there is minus 240 and 60. When we solve this, we get minus 4.0 meter per second. So this is the velocity of the final velocity of the Lele. So we find the final velocity of Lele. So we have to find the kinetic energy now. And find the kinetic energy for both. Then if we like do with the kinetic energy, so we can know that if the kinetic energy or not. So momentum is not there. So momentum is not anywhere there because we don't have any velocities for the initial. So if it goes out for the initial, so we don't take to the, we don't like do with the momentum anything. So we do with the kinetic energy. So first we have to find the EKI. The first one, the both are in rest, but initially, so we take on the final one. So half mv2f square. So EKI is equal to half m1. This both are m1 first. So first one is 40, second one is 6.0 squared, and we get about 720 joules for the first one, which is that. For the second one, I write over there something. So EKF is half M2 V2F square. So EKF is half, M2 is 60, and we have find this, so it's minus 4.0 meter per second square. This minus cuts out with square, and we get EKF about 480 joules. This is for Lally. So which one has the highest energy? So this has the highest energy initially. So that means that Larry has the less net energy. So this means it has the less net energy than that. So as I always say, this is the less and this is the large. So this means Lally has the less net energy than that. The next one, we have considered the head-on collision shown below. So we have over there P1, EK1, we have EK2 and P2. So when they collide, because it goes like this, when they collide and we get EK-1, EP1 dash, which is the finals, and this one the finals. So if the collision is lasted, so then EK2 and P dash 2 are what? Basically, this is also E2, EK2 dash. We have to find these two. So to find this, we have to use these two ones also. So you all know that when we find the EKI1, so what we deal with, like initials of the both, initial and of both. So what is initial for this? This is 49 joules. For the second one, we have 96 joules. From here, we get about 145 joules. For the P1I, we get the both one, like 14 kg dot meter per second plus 24 kg dot meter per second. In that case, that this is a negative. Why this is negative? Because if we take right as positive, so we take left as negative. So that's why those over there, like this is negative. So what is P1I? It's minus 10 kg dot meter per second. So they mentioned that this is the elastic collision. So if it is elastic collision, so this means that EKI is equal to EKF. So they both are equal in that case. So if they both are equal, so what is, this one is 145 joules. EKF, we have that 121 joules plus EK2 dash. We all know, and when we find EK2 dash final, this goes over there and there was a negative, and when we find, we get 24 joules. So we get 24 joules, and for same, for P2F, we have to find. So if it is last stage, so it's also the in last stage too. So this is in last stage too. So again, if Pi is equal to Pf, so Pi we have find minus this 10 raised to this, and Pf we have 22 kgs dot meter per second. This is in negative, and plus P2 dash, which is P2 final. We also write P2 final of this too if we want. So this minus goes over there, and when we calculate this, so we get P2F, or we can say P2 dash is 12 kg dot meter per second. So we get the EK2 dash and P2 dash like this family. So it's again the question of the conjugation of energy and classification of the two dimension or one dimension we do, but this type of question is like different type. We deal with that theory which we know about these questions. So the next one we have, so the collision is shown below. So it's kind of a collision we have. So remind the velocity of 5.0 kg mass after. So this is the last question we have to done today. So this is like a written response if we know. So this is the written response diploma question, and we have to know the things in this which we have to keep in the mind. So first thing, initially we have a lot of things. Firstly, we deal with only initial one because we want the final velocity of 5.0 after the collision, but we deal with the firstly initials one. So here we have P1, we have P2, we have angles for both, we have the masses for the both. In this type of question, we have two type of things. We have in this we have a two dimensions too. We deal with the two dimensions in this too. So we have the x component in up one and the y component of the next one because they are the respective values we have for the x and y component. For the second one, this after the one, so this is the after the collision. So we have the p1 dash and with nothing over there because if we this we have to find. We don't have the thetas too. We have theta for this but not for this. If we find for this as the x component and the y component for the this one, so then we also find this what is this x for the p1x. So we have 58 kg per meter per second. For the s component, we all know we have to find for the 58 kg meter per second for the cos 36 degree because the x is then the base. So this one is cos 36 degrees. So for p1x we find about 46.923 kg dot meter per second. That is for p1x. For p1y we take it as a negative because for p1y those to south. If we like make that, so it goes like this, it goes like south. So in that case we take north and east as positive but north south and the west is now negative. So this way for p1y we take this as negative of 58 kg dot meter per second and this is now sine 36 degrees. So for this when we find, we get about negative 34.092 kg dot meter per second. Now for this one, for the down one which is 27-degree angle, so this for the p2s and p2y. So for p2s, firstly we have 45 kg dot meter per second and we have to find for the x component, so we take cos 27 degrees and that p2x is equal to, if we find, so we get 40.095 kg dot meter per second. Again for p2y, now in that case we don't take this as negative because now this is like this, so it goes up, this is south and south is positive. So this is remains 45 kg dot meter per second and we have now sine 27 degrees. When we get the calculation done, so we get 20.430 kg dot meter per second. So we done this. Now for this one we have to find for this, which is p1 as final and p1y final. So let's move on to next page. We write p1 as final. So for this first one we have 51 kg meter per second, that's it. Yeah, we have 51 over there and we have 19 degree. So this is like cos 19 degree because we first have to with the x one. So this is sine 19 degree and when we find, we get about 48.221 kg dot meter per second. So if we find for the p1y final, so this is 51 kg dot meter per second at that time. So this is not, so this is the first one and this is the sine 90 degree. So when this is in a positive one because this is goes like over there, it goes like upwards. So when we solve for p1y final, we get 16.604 kg dot meter per second. So for the now we can done with only the half part of this sum. Now we have to find the x and y components. So let's move on to this part. So we have to find the x component. So this is again the hit and rebound one because they hit and they rebound. So for x component we have p1h plus p2h is equal to p1h final plus p2h final. So they both are in motion, and after and before they both have some velocities they have. So basically, what we have to find, we just find about this that P2 as final. So P2 as final, we have to find. So there's nothing in like we not have the velocities. We deal with the momentums. So we as we have momentum, so we deal with those momentums because we calculate these things all the momentums. So we plug in only the momentum thing, not we move on to the mass into velocity. So we get P1h plus P2h negative of P1 as final. So P1 as final, yeah. So you have to find that P2 as final. So that P1 as we over there, which is 46.923 plus for P2H, we have 40.095 negative of P1 as final, we have 48.1. So for P2 as final, you get about, when we calculate this, you get about 38.797 kg dot meter per second. So this is the thing we have to know. Then we have to find the y component. For the y, we take the same things, but in the y1, so again we have to find P2y final. So this is Py1, P21 minus P1y final. So that P1y we have about 34 point. So over there, so this is negative. So we have to take this negative, which is 34.092 positive plus of 20.430 negative of 16.604. So when we calculate that P2y final, make sure this is the minus over there, so you have to deal with that minus 2. We get a negative of 30.266 kg dot meter per second. So the main part again we have to done. We done that main part, and now we have to move on to the last part of this, which is resultant vector. So for the resultant vector, the first one we have this then positive, which is in P1s, which is goes to east one. So our P2h final goes east, and the second one goes south because this is in negative. And this we have to find, which is P2 final. Once we get P2 final, we get the velocity too. So this is the theta, this is the angle. So P2 final is equal to P2s final square plus P2y final square. So once you plug in the values, so for P2s final we have 38.979 square plus, we have to just make the negative is for the for vector resultant vector. Now we take it as positive if you want, because for the square they cuts out with negative. So P2 final, when we calculate this, we get about 49.206 kg dot meter per second. Now we have to find that thing, we have to find V2 final. So that's V2 final. So we know that P is equal to mv. So that is P2 final upon m2. So we know that this is 49.260 we have to find. Mass is over about 5.0, we know, for the second one. Okay. And when we calculate, we get about final velocity of about 9.8 meter per second. They didn't mention we want the angle, but if we want, so we have to find that angle too. So because this of course we have to complete in all the steps, because the theta is over there, we have to find the theta too. So for this we have to just do P2y final and P2x final. So P2y final we have 30.266 upon 38.976. When we find measure in degree mode, we get about 30 degree. So this is south of east. So this one we get. And now we have to find all the things in one scale. So we have to find that V2F. So we get about 9.8 meter per second, comma 38 degree south of east. So this is the answer for the which we want, the velocity of the 5.0 kg mass after collision. So this is that we found with the lots of work. So this type of written question, written response of diploma question. This is also very important. You have to do this by your own too once you watch all the video. So you can do that sum by yours. So that's all we have to do. So that's the end of the unit. So we completed the momentum and impulse. So this is the end of the easy unit, but like the rest of three are like some unit which are like some tricky part. In this is the easiest unit of physics 30 or the grade 12 physics. So this is the end of the unit of momentum and impulse. So in next video we'll move on to the next unit, which is the forces and fields, unit B of this, which is like a big unit as compared to all the three. And so learning made simple with EduVibe, learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.